entropy and the universe play a very close relationship, right? Because and I think we can start this pretty cool idea where the heat death could be caused because of entropy, right? Because entropy, again, as we were talking about the maximal disorder, when does that happen? When it's equal probability for all events. So in this case, in the case of thermodynamic equilibrium, when we're talking about the whole universe, the maximum entropy, the absolute maximum possible entropy of the universe will occur when everything is at the same temperature. So the whole universe is in thermodynamic equilibrium. And when
I think that can only happen when there are no more stars nor black holes. Because black holes do evaporate very slowly.
Mm-hmm.
And eventually, like, stars will die before, like, the black holes evaporate. Mm-hmm. And so the universe will get to a point where there are just no more stars. It is just a black universe, and you will see, well, you won't see anything, but there will be black holes just peppered all over the place. Mm-hmm. And some black holes will become super massive black holes as they start to attract each other very slowly, just like how gas clouds can attract each other very slowly to become a star. I think the black holes will actually, now that I think of it, I guess it will happen like relatively locally, but because the universe is expanding, just like for us, we'll never see, like, some stars we'll just never see because they are moving away from us faster than the speed of light. And so that will be the case for some black holes. They'll just spread out everywhere. And as they all finish to evaporate, it will just be kind of this isotropic black soup of matter that is just all the same temperature. And at that point, a very long time from today, there will just
very
be
long.
A heat death. The entire universe will just be the same, literally the same, everywhere you look, everywhere you go.
That would be very insane. Also, just a quick, very insane. Oh, quick clarification: the galaxies don't move away faster than the speed of light.
Yeah,
it's space
just
that's
space,
technically space that's being created faster than the speed of light. So it gives us the illusion that the galaxies are moving away. But yeah, I mean that's an interesting point. Like that will be, I mean that is a potential future for our universe, right? Like when all of these black holes, when all of these stars basically dissipate into, like, the absolute end would be probably when all these guys are just protons and neutrons and just like bunches of just matter floating around, all in equilibrium.
Well, I think there will still be like elements floating around, because how do you really decompose the elements into protons and neutrons?
Let me bring up a quick thing that I'm reading. Maybe I can put it in the description. Just we should remember a quick thing that I'm reading. I just want to quote something out of here, like in case I don't get anything crazy wrong. But this one article that I'm reading is that in the far distant future, stars would have used up all their nuclear fuel, ending up as stellar remnants such as white dwarfs or black holes. They will eventually evaporate into protons, electrons, photons, and neutrinos, ultimately reaching thermal equilibrium with the rest of the universe. And then they continue on to say that this process of cooling down can take, can take 1 followed by 100 septillion. That's 10 to the 26 zeros. So that's how long it would take. Years. Those are how many years it would take. And then the temperature would drop to almost like near 0 Kelvin, near absolute zero. So, I mean...
Wait, the temperature would drop to 0? Is that because the universe is expanding? So
yeah, so it's weird because it's called heat death.
Yeah.
But it's not really heat. You know, it's lack of heat.
So wait,
because it's expanded to such a large space that there's like not enough heat for the whole universe to continue. Like stars would not be able to form if all the matter is just so...
How is that possible? Because then that would be entropy zero. If everything just stops moving.
Hold up. Hold up. Wait.
Houston, we have a problem.
Wait. What?
I mean, I don't know. I don't
Okay,
think
again. No.
temperature goes to
What?
zero.
No. Well, this is an interesting
I don't think temperature goes to zero.
well, it could take as long as so many years with the temperature dropping to around 10 to the negative 30 Kelvin. That's what they say.
That's not zero.
I mean, it's not zero,
That's not
obviously.
zero.
Well, it's not
No.
going to achieve zero. I never said zero.
Because no, entropy zero is only defined at like 0 Kelvin, right?
Yeah, so 0 Kelvin will just not happen. That would just not, no.
But even if there's a really, really low temperature, if it's spread out over the entire universe,
Exactly.
then
That's
we will
exactly
still
it.
have like
That's
an
exactly
insane
it,
amount
'cause
of
volume,
entropy.
right?
Yeah.
Right, because it's about how big the damn thing is too.
Yeah.
Right? Like, because we have this huge universe. Sorry. We have this huge universe with, even though it's such low temperature, the entropy, I do not believe will go to zero. That would just not happen, because it will have to increase. It would just keep increasing again. But the thing is, it would increase until it reaches that maximum entropy, right? Because we were talking about earlier how all systems have a maximum entropy where
I think
you can't put any more work, unless you do work on the system, which is different. Internally speaking, there will be maximum entropy at some point. So if we're talking about the whole universe, remember, the whole universe, we can't really put in energy from outside, because any energy we put in to the universe is technically internal, because we're in the universe. So when the universe ultimately reaches this maximum entropy regime, right, nothing will be able to happen. We would not be able to do work on the universe. The universe will not. So it will just be stagnant, basically. Nothing would be able to happen. And like all the energy would just be, random motions of atoms and molecules in the universe. That would be it.